Okay, so hi everyone. I'm Carlos also, and I will present here ofxPython, which is kind of a library that I made for a specific purpose of embedding Python into C++. I guess C++ is not your favorite language here, is it? Okay. So just a few words about me. I'm Carlos, and I come from a context of human-computer interaction. That means just creating interfaces for talking to machines, etc. And in a world of creating creative applications or real-time applications, this kind of visual and audiovisual things, etc. And I love it with Python. I really like Python, the way it expresses ideas, behaviors, etc. I'm also a founder of ProtoPixel, a company about interactive lighting experiences, and I also work in the University of Fabre, the music technology group. So, yeah, so first, some disclaimer, there is C++ in this presentation, don't be afraid of it. I will be talking about CPython and always talking about CPython 2.7 version. I don't know if any of the things I do apply to Python 3 or to other PyPy things, but probably you can do some stuff the same way. Also, this presentation is online, so I guess now it's better than the last time, but if you have problems reading, you can just go here in this URL and it's good you have it on your screen. And I will show you some demos. We'll do some live coding here. The thing is that I was rehearsing this presentation yesterday with my flatmate, and he was at the end really confused because it was a very dense presentation. So it is online, so I won't go in depth. I will be really light in some of the parts that are more C++ related, etc. So we can have more time with the demos, and if everyone is more curious about the thing, I'm here and the presentation. So I'm presenting here the ofxPython library, which is more specifically an add-on for embedding Python in open frameworks. And you can find it here in GitHub. The thing about the name, ofx, means there's an add-on of open frameworks, and you can see this thing around and around in the world of open frameworks. I will talk about this. You probably don't know about open frameworks. Open frameworks is like a toolkit in C++ for creative coding. So it just it's a toolkit that allows you to do just this kind of visual stuff and whatever visuals, trying to control physical things, blah blah blah. And this is kind of related to the work that we do in our day-to-day. So it is in C++, and it basically takes several libraries for drawing, for making sound, for analyzing 3D things, whatever. And it just takes these libraries and makes a consistent naming and programming idiom. Just creates a bunch of classes that they look like, and they're a similar way of interacting with these classes, etc. It's very popular for creative developers and creative coders, and something that's really nice, it has a lot of third-party add-ons. So just the community gives back by creating more libraries that integrate with open frameworks. And it's also free and open source. You can use it for whatever you want. If you know about processing is a toolkit in Java to start learning programming and creating like interactive programs with it. It's kind of the same thing, but in C++. So it's kind of nicer because it's not Java. So when you're developing your support product in C++, so you could ask yourself, why do you want to have scripting in it? So why did we start even this thing? One of the problems that you want to solve maybe is allowing the user to add something to the program, so to create their own content, interactive content, or to create their own classes of things. That this code that the user can create, and he doesn't have to recompile anything, just test it on the environment, etc. Or maybe you want to have a plugin system. You have like the application coded in C++, it's compiled, you don't have to change anything, and you can bundle new things with your software. They can be updated very easily, etc. Or maybe you want just to prototype and just try new things without having to compile, because in C++, whenever you start doing difficult things, it's kind of a mess to have to compile every time. And specifically, why using Python? First, because we all love Python. But then because of the batteries included. So Python bundles with a lot of libraries that are really, really neat. For instance, something that we use Python in our C++ code is to relate to JSON documents. So we don't have to touch anything in C++ with JSON. We can just use Python as a proxy way to deal with this kind of things. And also because all the other libraries on the Python package index you can fetch. So let's put Python on it. So if you want to embed CPython into C++, you have to solve two problems. One is the ability of Python to call C++ code, and let's call this extending Python. And you also have to solve the problem of C++ code to call Python code, which is called embedding. If you are embedding, you probably need the two pieces, because if you are if you allow the user or whatever person to code in Python and the application to execute this Python program, probably you want this Python program to do something with your application. So the Python part has to communicate with the C++ part. So how we approached these two parts. First of all, for the embedding part, so putting Python in C++, there are mostly two different ways of doing that. One is using the C API of CPython manually. This means dealing with the reference counting, means using a C-based ugly API where you have to use row pointers with things. It's kind of very difficult. It's very easy to get the things wrong, really. And you can also use this Boost Python library. It's based on C++. It's kind of nice. It wraps the Python objects into C++ classes that you can interact more or less like you would do it in Python. But it's if you know about Boost, Boost is a C++ library that tries to implement the parts of C++ that will be standard at some time in the future. It's very difficult to install. Every time that you are updating it, maybe it's not backwards compatible. It's kind of difficult to deal with. So we basically took the CPython C API and wrap it into some simple C++ classes that to deal with all the C API. We'll see that just briefly now. Yep. And for extending Python in C++. So exposing all the open frameworks functionality into Python world. There are more alternatives. We've seen here the CPython C API and Boost Python. Both require you to describe all the C++ classes and all the functions and whatever that you want to use in Python to describe them manually. So it will be this function, and you'll have these members, and you'll have these methods, etc. Which is not really convenient. There is also C types. You can do it with C types, and it's kind of the same thing of using the other tool, but in Python. You describe the API in Python, but again, you have to write it everything. There is also this C foreign function interface module in Python. It's a very nice and new module that you can use to connect C++ or C to Python. It uses the compiler to create the bindings natively, and it can do it at runtime, which is nice. But it's automatic. It will discover all the classes and all the functions that you want to import. But it's difficult to customize. You cannot say, okay, I don't want you to import this class, or for this class I don't want these members because they are dangerous or something. So here we basically use Swig. Swig, probably you've heard of it. It's a program that will analyze C++ header files, all the descriptions of the class, etc. in C++, and will generate all the glue code to relate to this code. But you can also customize it very easily. You can say, this class, I want this class, I don't want this class, I want to change the name of this other function, whatever. So it basically works like this. You write here the interface file. In here you say, you describe, I want to use this header file, but please don't import this class and whatever. It will read this interface file on the header files of C++ and generate these two different glue code files. One that you will compile with your application, and another that is a Python module that can be imported from Python. For instance, here we can see this, that would be the interface file for ofxPython. That's just a part of it, but you can see here that I'm just including a header file. I'm saying please ignore this class because I don't want you to use this class, whatever, there's lots of things. Here I'm just creating the properties for functions, blah, blah. And Swig just eats this and creates this shitload of code that is kind of very difficult to understand, but it compiles. If you have something difficult, if you have an error here, it's kind of very difficult to know what the hell is going on. But it's a very big thing, and yeah, all the time like this. And it also creates this Python file, which is the same for the Python. You can see here, it's just a part of the Python file. You can see all the constants at the beginning, and then just a class, and all the methods of the class, and some functions, etc. So, this is the part where I go fast, and I don't want you to pay a lot of attention because it's kind of C++ code all the time. But basically, ofxPython comes with two big important classes. One of which is ofxPython that handles the interpreter and holds the scope. It holds like the global variables of the code. It's like a module. And can execute arbitrary code. You can say, okay, execute this script or execute this string, whatever. And it accumulates all the globals, so it's like a tiny Python world that you can have. It's not a separated interpreter. That's important. You can have two different ofxPython instances, and they will have different global variables, etc. But if you, I don't know, want to modify post.path or something like this, it will be modified for all the ofxPython worlds or scopes. Then the other important class is the ofxPython object, which is the simple wrapper around a Python object, and it handles all the reference counting for you. You don't have to worry about anything like this. And yeah, you can create these ofxPython objects in many ways. You can extract them from the ofxPython object, like from a module, importing from an external module, for instance, or you can construct them from C++ values. So you can just have C++ integer and create a Python integer with that in order to do stuff with it. Then you can check if it's bool or integer or float or whatever, so you can know what you're dealing with. Or you can extract C++ values from these Python objects. So just you have Python objects, you know it's a float, so you can just call this as float method, and you get the C++ float type. So you can retrieve information. And then also, have a whatever object, you can call it like a function, you can instantiate a new instance, or if it's a class, or you can access attributes, or assign attributes, or call members. These are some special useful parts of xPython. One is the ability of passing callbacks. So you create some C++ code that you want Python to call sometime. So you create the code, wrapped in a class, and you can convert this into a Python object and just put it on the scope, or just use it as an argument in a call to a Python function, whatever. So this function can call you back in C++ in real time. This is very nice to have, for GUIs, or for when you don't know at the compiling time whether the Python will call C++ code or not, depending on something. Also, it has some error checking, so it doesn't crash and miserably fail. It checks for errors, exceptions that has been raised, etc., and they are ignored when it just says something on the standard output. And if you want to know if something some object can be used, you just use it in an if statement or something. It's because ofxPython objects that are invalid evaluate to false, so it's easy to know if you can use them. And it has threading, but Python threading, because Python has this thing of a global interpreter block, and every operation that you do will acquire this global interpreter block, and will acquire the lock and will perform the operation. It was myself, no? Oh. Okay. But you can, if you want to block the global interpreter lock for more time, you can use this ofxPython operation thing that will help you to do many different operations with Python, and don't be afraid that any other Python code can change things in the meantime. And it also has ways to add paths to the interpreter or using a virtual environment, etc., which is very useful to have. So now it's the demo time. Let's see here. Yeah. So yeah, it's okay the size of the code. So very briefly, this is like an open frameworks application that tests Python programs. Here is like the class of the application, and it basically has some members for setting up all the application, and these two update and draw that will be called every time that a frame has to be drawn on the screen, and some callbacks for the keyboard, for the mouse, etc. And here we have the Python ofxPython context, and Python object, which is our instance of a class that we will instantiate, that we will be using. And here at the setting up the application, we just initialize the interpreter. We say, okay, execute the script, this one that I have here, I will show you. And we retrieve a class that is called myapp, and we create this instance of this class. And every time that we have this update or draw, we just get the member update or draw of the class and just call it, like we would do it in Python. That's all the things that this application does. And this is the class that we will be testing. Let's see. Okay. Now this class it doesn't do anything. So you see the pass every time here. We can try to have something really simple that would be drawing like a rectangle, which would be a square with the same size here, and rotating it on the screen. If you know something about OpenGL, etc., this will look something familiar. To explode it, this is the result. So we are just setting the color and then translating the view and rotating and then creating this rectangle. And we can do something more interesting. So here I will uncomment this. Instead of having this one object, we'll have like lots of objects, like 400 objects that we call circle in a list, and every time we update and draw all the objects of the list. So here we have this circle object. For drawing it, we just draw the circle in its position X and Y with a size. But the really interesting thing is that with Python, we can use coroutines, so basically generators, to create behaviors. So here, our circle will be initialized with a direction, with a position and size, and then for some random number of frames, it will do absolutely nothing. And then it will start growing its size, so the size will be growing all the time. Every time that we hit yield, it goes to the next frame, so it stops, the next frame is resumed. And here, until we are outside of the screen, it will just go into the direction we have set up. The direction will be randomized somehow, and will go, well, this direction will try to go more or less to the bottom left of the screen, while we are decreasing the size. So let's try this. So this is like the result. So every one of these tiny circles is one of these instances of the class. If we want, I don't know, change the color here. We can change to something like pinkish. And before we go, we stop, or we go to the end of the talk, I wanted to show you what we are actually using this add-on for, the Python in the C++ for. This is a program that we are making in PyPixel, which is used to control, let's say, to control light, to create interactive lighting experiences. But the interesting thing here is the parts that we can do in Python that makes us our life less miserable. Like here we have like different fixtures. Fixtures are collection of lights in a shape that we can instantiate, like this matrix here. We have here, and this matrix is actually a Python file here, matrix, that describes with this list comprehension where the position of the lights are really. And we also can have these variables exposed as parameters that we can change. So just by inspecting here the Python file, we can have the different variables that we can change and affect the way it looks like. This would be a way of creating plugins with Python in a way that we don't have to code everything in C++, which is okay. Let's see. Just so you have a another interesting thing that we are doing with this Python embedding is debugging. And here we have like a console where I can put Python code and I have access to all the internals of the applications. I don't know. Obviously, I can add numbers, but I can also import the internal part of the applications and the application and see what. So I see all the internal functions where I can change things or try to know what's going on wrong with the application. And yeah, this is more or less the parts of the demo. And yeah, questions, or if you want to afterwards talk to me about real-time interactive Python, which I think something that lacks in the Python community, or creative coding with Python, or embedding Python in C++, or whatever you want. So feel free to approach me. Question?
One question. You were showing you were instantiating in C++ these Python objects, and then you would be calling. You had some methods. The methods you were calling the C++ functions. I understand these are kind of hard-coded in the library. You want to call arbitrary functions.
So imagine here, yeah, here if you have this Python object here and you want to access the attribute is attr. So we don't have like custom C++ name for the Python object.
Do you call arbitrary methods on the object? How do you go about it? You need to retrieve the method as an attribute and then call it somehow? Or?
Yeah, like this.
Okay.
So you have this access to the method and call it. Because the method is also a Python object. So
Can we use this from Python only? Like write a script in Python and do the drawing then?
Well, no. The thing is, I don't know why. Well, I know why. It's a complex issue. Part of the code of open frameworks is compiled in a way that it's not, how they say, position-independent code or something like this. And you cannot create a library of whole open frameworks toolkit because of that. If it wasn't for that, I would say that that would be the solution. But it's kind of difficult to compile or to modify open frameworks in this way to use it. But I tried that at the beginning, and at the end I ended up by embedding Python, so it was easier to port everything like this. But you can use all the other libraries from here.
Do you have any benchmark of a complex application to see to which point is useful for production?
No, I don't have benchmarks. I would say Python is embedded Python is as slow as Python. So it's if you want to do so if you want to do something in Python, do it because it's easier to write or easier to maintain. But things like, I don't know, adding to arrays of 1 million items, like this, don't do it in Python. But I don't have any specific benchmarks. I just show this demo of 400 objects because in my other laptop, after in 500 objects, it was starting to be lagging. So I wouldn't say that you can use that to do anything. It's better to use it in the parts that make sense. Okay, I think have a coffee break or something.